The easiest paper till now. This paper is conducted on 24th January morning session paper. So in this case, the first question is just vinyl halide, allyl halide, benzyl halide, aryl halide asked which are matching to this. Vinyl halide means this one, halogen connecting to sp2 carbon directly. Allyl halide means halogen connecting carbon is sp3, it is sp3 that is connecting to sp2 carbon. Benzyl halide is this one, halogen connecting carbon is sp3 and that is connecting to phenyl group. Aryl halide is this one, halogen directly connecting to aryl group. Coming to the next question, so accordingly answer we can see. So just ABCD only, right? 1 2 3 4. Coming to next, correct the stability order for the diazonium ion. So diazonium ion is electrophile, diazonium salt, N2 plus Cl minus. Here this is positive group. If it is with negative groups, stability is going to decrease, so that whichever is having positive connection, means whichever is having electron donating groups, either plus R or plus M or plus H or plus I, those get stability. So NO2 is strong withdrawing group than Cn, Cn also withdrawing group. In this case, next option is no connection in this, so just without any group, and OCH3 is plus group. So accordingly, if you see, NO2 is strong withdrawing group, and then Cn, then OCH3, because nothing is there. These are plus R group when it is connecting to conjugation, otherwise it is minus I group, but in this case it behaves as plus R group. This is minus I group, NO2 is plus minus I minus M group both. That's why the order of stability of benzene diazonium salt is stability of benzene diazonium salt or diazonium is directly proportional to electron donating groups. So accordingly, we can say fourth option, D is more than, C is more than, B is more than A. This is the order of stability, students. Coming to next, which of the following compound contain 3 unpaired electrons? So we have to see the unpaired electrons order in this. V2O5 if you take, so total oxidation state of oxygen is, so vanadium if you take, atomic number, scandium, titanium, vanadium, so 23, so 4s to 3d 3 will get. In case of this 2x plus 5 into minus 2 equals to 0, because oxygen is monoxide, 2x minus 10 equals to 0, x equals to plus 5. To get plus 5, all these electrons should go out, so 5 electrons should remove from this, so that we will get V like V plus 5. V plus 5 means 0 unpaired electrons, means 0 electrons. So similarly, this is fourth question. Second option, if you see, oxidation state of TiF6 minus 3 if you take, so x plus 6 into each minus 1 ion fluoride, so minus 3, which is equals to plus 3, so this is plus 3. So scandium titanium means 4s to 3d2, so in this case 1 unpaired electron you will get after removing 3 electrons, because from this 3, from this 1 we remove, so you will get 1 unpaired electron. Coming to next, COF6 minus 4, so COF6 means CO plus 2, you can same way you can do it, plus 2, so that means valence electrons are argon 4s0 3d 7, because 4s2 electrons removed. So according to Hund's rule, how many unpaired electrons we can write? 1 2 3 as like this, So 3 unpaired electrons we can get it. So 3 unpaired electrons in this. Similarly, FeCN taken 6 3 minus. So Fe atomic number plus 3. So oxidation state 4s0 3d. 3 electrons if you remove, you will get 3d5. So total, according to normal Hund's rule, you will get 5 unpaired electrons. But here ligand also matter. Earlier it was weak field ligand, so we are taking directly. But according to ligand strength, those 5 electrons filled. Sorry. 5 electrons are filled as like this. 1, 2. Hund's rule wise 5 electrons are like this, but this is coordination number 6 complex. So T2Z will be at the ground level. So first 3 electrons are filled. Then since the ligand is strong filled, the CFSE value is more. The 4th electron cannot go to EZ level. So it will come to T2Z level only. This is T2Z level, this is EZ level. That all comes in CFT theory. So anyhow, how many unpaired electrons you are getting resultant? Only 1 unpaired electron. So accordingly we can find the number of unpaired electrons. 3 unpaired electrons answer will be, so just CO F6 minus 4. Hope it is clear, students. This much time should not take for solving question. You can easily analyze if you practice. Coming to next, consider the following molecule, correct order of dipole moment. So here the first molecule is this one, orthonitrophenol. Second molecule is phenol. Third molecule is toluene. So in this case, orthonitrophenol and phenol and CH3. You can take CH3 here to avoid confusion. See, NO2 is strong withdrawing group and OH is plus R group. Generally this give electrons to the benzene ring to make resonance. So what happens? The electron cloud is moving towards NO2 side, and NO2 is electron withdrawing group, so strongly pull electron towards down. But in the second case, here also due to resonance the electrons enter into the ring, and here also the resultant electron cloud is towards downward direction. But NO2 is strong withdrawing group, the electrons pull strongly towards downward. But in second case not like that. Second case is just electrons enter into benzene. But in case of CH3, here plus I group is present, means alkyl groups are plus I groups, or methyl is plus I group. So electrons, sigma electrons displaced towards benzene ring. But the effectiveness is less in case of last option as comparatively second option, because plus R effect is more than plus I effect. So accordingly, what is the answer? A greater than B greater than C. If you consider this is A, this is B, this is C. So that's the answer, students. Coming to next one, which of the following compound give positive tolerance test? See, positive tolerance test, how to analyze? See, the first thing, tolerance test is used to separate aldehydes and ketones. That well known. And in some cases, even ketone will give positive tolerance test, like fructose. But what kind of ketones will give positive test? Alpha hydroxy ketones. Alpha hydroxy ketones gives positive tolerance test. Condition 2 is hemiacetyl link. Hemiacetyl link compounds give positive tolerance test. Acetal 1 doesn't give positive tolerance test. So what is hemiacetal link mean? Just simple. In any case, aldehyde or ketone present, when we add ROH, it will give hemiacetal, which is suppose if you take aldehyde, you will get a hemiacetal. It will be like this, OH, OR. If you add one more mole of ROH, you will get acetal, means this is hemiacetal and this will be acetal. Like one more means this H also replaced with R. So what happens here is just so here we will get OR OR. So this is called acetal. So hemiacetal means the center or carbonyl carbon, one side OH, other side OR. That is called hemiacetal. Suppose acetal means both side OR groups. So accordingly we can find the answer for this. So options wise, what are given is just the first option is like this. So in this case, this is the carbonyl carbon. One side oxygen is there, other side means one side OR group is there, other side OH is there. So that it is called as hemiacetal link. Hemiacetal gives Tollens reagent. This is A option, B, C and D. So first option ready to give which one? Acetyl, hemiacetal, so it will give positive test for Tollens reagent. But in this case, this is just ether, it's not hemiacetal because this is away from the O. That's why it is normal alcohol and ether functional group, so that won't give. And coming to this is aldehyde. Aldehyde will give this one. This is ketone, so this will not give Tollens test. So accordingly, what is the answer? A and C are the answers. So this helps for the biomolecules also. Mostly biomolecule questions are linked to this. So even sucrose doesn't give Tollens reaction or Tollens test due to presence of acetyl link. Coming to next. This accordingly A, B, A, C only. These structures whatever I wrote, this in statement form, but normal naming wise given. These are the formulas. Accordingly A and C options are having answer. Coming to next. So this is, there is a question here. The question is like this. A reacting with SnCl to HCl to give B. This is B product. B over KMNO4 and H plus got C. C over Cl to P red phosphorus with H2O gives D. So accordingly what will be the option? So in this case options are given like this. So this one, the final product has one chiral center. The structure of A will be. So it's very simple. One by one we have to cross check. We'll try for first one only. This is Cn over Sn plus HCl, SnCl2 plus HCl after hydrolysis. What you will get is just, this is called Stephen's reduction, right? So we will get CHO, very simple. And over strong oxidation, CHO becomes COOH. So COOH will be formed here, and after that Cl2 with phosphorus and H2O. So this is acid chloride is formed because this is used to make PX3 or PCl3, which is chlorinating agent. It replaces OH of COOH. So you will get COCl. Further, red phosphorus. Oh sorry, this is red phosphorus plus H2. Red phosphorus and H2 will not give this one. No, it is sorry HVZ reaction, right? Alpha hydrogen replaced with this one. So Cl will be added here. So answer will be, this is HVZ reaction. HVZ. This is Stephen's reduction. So accordingly, what is the answer? First option is having chiral carbon. This is chiral carbon. One side COOH, other side CH3, and this is H. So together if you consider, so this product is having optical activity or having chiral carbon. So answer is first option only. No need to go for next. because SnCl2 itself decide which option is correct among the following. Either third option or first option, but third option doesn't have these things. Next one, consider the following reaction. K2Cr2O7 I minus H plus I2 gives rise to these products. So very simple, these are the two reactions. So equation I will write it. 6I minus plus Cr2O7 minus 2 plus 7H2SO4 gives rise to 3I2 plus 2Cr plus 3 plus 7SO4 minus 2 plus 7H2O. So here just we have to balance the equation, so you will get the answer. In this case, K2Cr2O7 plus 3s power minus 3 sulfide ion gives rise to 2Cr plus 3 plus 3s. So here x value we can take it as 2, y value we can take it as 2. So answer will be 4. Just you have to balance this equation. After that you will get to know what is x, number of electrons exchanged per mole of I2. So here simplified way if you write it, so 2 moles of Cr2O7 converted into 2 moles of Cr plus 3. So 3 moles converted into 3 moles of sulfide. So if you neutralize that, you will get only 4 electrons, x plus y value. Coming to next, correct order of stability of the following species. So they have given 3 benzyl carbon ion. So very simple, carbon ion stability directly proportional to negative groups. So carbon ion stability directly proportional to negative groups. That means whichever is having more negative group, that is more stable. So this is more stable, then this one, then this one, then this one. So answer is 1, 2, 3, 4. So that's the option. Sorry, unsubstituted also given, no? So unsubstituted will come as 4, this will be 5. Accordingly we can take, because this is the key point. And coming to next, hybridization and related shapes. IF3 minus, if you take total 7 electrons, 1, 2, 3, 4, 5, 6, 7. So surrounding fluorines are 3, 1, 2, 3. So 1, 2, 1, 2, 3, 4, 5. So sp3d hybridization with 2 lone pair of electrons. So IF5. So sp3d with 2 lone pair of electrons means, so the sp3d without lone pair is trigonal pyramidal, and with 1 lone pair seesaw shape, 2 lone pairs is T shape. And IF5 same way, valence electrons of iodine 7. So accordingly 5 are connected, there will be 1 lone pair left out, together 6 sp3d2 with 1 lone pair. So sp3d2 with 1 lone pair is square pyramidal. IF7 means 7 electrons and 7 hybrid orbitals. So sp3d3, 7 hybrid orbitals, in the sense what, 1 s orbital, 3 p orbitals, 3 d orbitals. Together is what, 3 plus 3 plus 1. So together 7. So that sp3d3 without lone pair. ClO4 minus means total electrons of Cl is 1, 2, 3, 4, 5, 6, 7. But minus is there, right? So we have to add 1 more electron. Each oxygen bind with 2 electrons of central atom. If anyone don't know this format or this trick for hybridization, you can watch complete video which is in the channel. So don't miss. And you can also comment which shift you wrote in exam. Consider the following alkenes. So which alkene is more stable? So alkenes, I am going to write it. These are the alkenes. First alkene, just so the alkenes I am writing. One, 2, 3, 4. So these are the 4 alkenes, and asking which is more stable. Very simple question it is. More the hyperconjugative structure based the question is given. More alpha hydrogens, more stable the given alkene. Stable alkene. So our high substituted alkene is more stable. So here alpha hydrogens you cross check. So CH3, CH3. So total how many alpha hydrogen? This is a double bonded carbon. So beside carbons all are alpha carbons. So together 12 alpha hydrogens are there. Here this is alpha carbon, this is alpha carbon, this one. So 9 alpha hydrogens are there because everywhere CH3. This is trans and this is cis. So trans is more stable than cis. So that 3 is more stable than 4. So what is answer? Stability order is A greater than B greater than C greater than D. That's direct question only. And coming to next one. So here phenol reacting with Na and produce phenoxide ion and H2 gas. And same way, because sodium is replacing hydrogen from this, and COOH over NaHCO3, we will get COONA plus H2CO2. H2O CO2. So which gas is released here? CO2 gas. They are asking just what gases are released and what is the molecular mass of together. So very simple. So here H2 gas is released, here CO2 gas is released. So H2 is X, this is Y, and asking what is the molecular mass of X plus Y. That means 2 plus 44 equals to 46. So the answer is 46. Coming to next. This is directly POC chapter, practical organic chemistry. So here X condition is what? Sparingly soluble in cold water. So sparingly soluble one is PbCl2, and similarly Y will be AgCl, sparingly soluble at room temperature, and this will be sparingly soluble in hot water is Z. So answer will be third option. And coming to next, what is the hybridization and related properties of this? Very important. COCl6 Cl3. So oxidation state of CO will be plus 3 because Cl is, this is CO, this is carbonyl neutral ligand. So oxidation state with respect to CO 0. So X plus 0 into 6 plus 3 into minus 1 equals to 0. So X minus 3 equals to 0, X equals to plus 3. So oxidation state of CO will be plus 3. So CO plus 3 means resultant configuration is 3D, generally 3D to 4s7, 4s to 3d7. CO plus 3 means directly I am writing 3D 4s to 3d6. So how many unpaired electrons are there? 6 unpaired electrons we will get. So 6 unpaired electrons means, but CO is strong field ligand, so accordingly it will break and write the electronic configuration. So you can see all electrons enter into T2G only. So T2G6 Eg will be 0. So T2G6 means all electrons here. So T2G6 means is there any unpaired electron? No unpaired electron. So that the hybridization is D2sp3 because strong field ligand, D2sp3 and 0 Bohr magneton. So option 1 is only correct. So that's the answer. Coming to next, elevation boiling point. So here a non-volatile solute A mass is given, non-volatile solute B mass also given, and dissolved 100 ml of water at 27 degrees. So what they are asking is delta TB value, pi value they are asking, osmotic pressure, correct? So here elevation and boiling point they are asking. So what is elevation and boiling point we can discuss here. So number of moles, first you will calculate number of moles of A. Number of moles of A will be 0.3 by 30, which is equals to 10 power minus 2 mole, and NB equals to 0.9 by 90 equals to 10 power minus 2 mole, because molecular mass of that is given. and what we can write it is 10 power minus 2 by, that's